أعزائي طلبة وطلبات شهادة الثانوية العامة قسم الرياضات، أهلا بكم. النهاردة إن شاء الله هناخد درس في الديناميكا اسمه القبل اللي هو الازدواج. وإيه هو الازدواج؟ تعريف الازدواج طبعا في قوتين بيبقوا متساويتين ولكن خط عملهم ليس خط عمل واحد، فده اسمه درس الازدواج. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson in dynamic. It's called couple. What is the meaning of the couple? In the last lesson we know that every two forces equal in magnitude and the opposite direction is third law of Newton. The couple, we have two forces equal in magnitude but opposite in direction, but the line of action line are not same straight line. It's called the couple. Dear student, look at the definition of the couple and problems on it. Dear student, what is the definition of the couple? It is a system of two forces are equal in magnitude, also in opposite direction, and acting in different line of action is called a couple. If the system of two forces, couple means two forces equal in magnitude, opposite direction, but acting in different line of action is called a couple. Moment of the couple. Look at, dear student, moment of a couple, distant or norm moment of the couple equal norm distant times force vector. Look at moment M equal F times L. F means a force, L is the distance. We have two directions of couple. The first graph represents positive couple in direction anti-clockwise, but the second graph represents the negative couple is negative FL in direction clockwise. The moment couple equals AB times F sine theta. Then the moment of couple equal F times L. Important rules. If three coplanar forces act on a raised body and they are completely represented by sides of triangle taking in the same cyclic order, then the system is equivalent to couple. The magnitude of each couple equal K, the ratio F over L. Look at ABC, three forces act in three sides of a triangle in cyclic order. Means there is a relation between each force and each side. F1 over AB equal F2 over BC equal F3 over CA equal constant ratio. This constant is called K. Example. ABCD is a parallelogram in which AB 12 cm, BC 8 cm, measure angle A equals 60 degrees, forces of magnitudes 6, 10, 6, 10, gram weight, kilogram weight, act on AB direction, CB, CD, AD respectively. Prove that the system is equivalent to couple and find its moment norm. Solution. Look at ABCD is a parallelogram. The force 6 act on AB. The force 10 act in CB. Also, force 10 act on AD. Force 6 act in CD. Look at the student. The length AB equal 12 centimeter, BC equal 8 centimeter. What is the BE? Look at BE equals AB sine 60. Why? Look at triangle ABE. ABE has measure angle A 60 degrees, measure angle E equal 90 degrees, then 60 sine 60 opposite over hypotenuse, BE over AB, then BE equal AB sine 60. Remember, what is the BE? Distance between two forces, 10 kilogram weight. DH also the distance between the two forces which act in AB and CD. What is the BE? 12 sine 60, sine 60 root 3 over 2 equals 6 times root 3 centimeter, BE. DH, the distance between two forces which act at CD and AB equals AD sine 60. AD equals 10, 8 times sine 60, 8 times root 3 over 2 equals 4 root 3. Then the two forces 10 and 10 form a couple. Its moment M1. M1 negative 10 times BE. Why? Because this couple, its direction clockwise with negative sign. M1 negative 10 times 6 root 3 equals negative 60 root 3 kilogram weight, that centimeter. Also, the two forces 6 and 6 form a couple. Its moment of the couple is M2 equals 6 times DH. 6 times 4 root 3 equal 24 root 3 kilogram weight, centimeter. Remember, dear student, unit of the couple equal unit of force times unit of the test. Unit of the force, kilogram weight. Unit of the distance, centimeter. Then unit of the couple is kilogram weight dot centimeter. We also, this set of forces from a couple, its moment M equals M1 plus M2. We add M1 plus M2, the moment becomes negative 60 root 3 plus 24 root 3 is negative 36 root 3 kilogram weight dot centimeter. This norm of moment as positive sign must be equal positive 36 root 3 kilogram weight centimeter. Dear student, translate to another example. ABCDHO regular hexagon, the length of whose side is 8 centimeter. Remember, hexagon regular means all sides equal, all angles equal, measure of each is 120 degrees. Forces of magnitude 38 kilogram weight act along AB, CB, DH, OH respectively. Prove that this system of the force is equivalent to couple and calculate its moment. Solution. Look at regular hexagon ABCDHO. Each side 8 centimeter. Remember, measure of each angle is 120. We have forces 3, 3 act in AB and DH. Also 8, 8 act on BC and HO. Look at, dear student, BH equal 16 centimeter and AO 8 centimeter. First, we calculate AH and PO. Why? AH distance between the two forces 3 and 3. BO distance between two forces 8 and 8. Then AH equals 16 sine 60, 8 root 3 centimeter. BO 6 root 3 centimeter. Why? Because the angle ABH equals 60 and angle angle AHB equals 30 degrees. The set of the forces consists of two couples. M1 is 3, 3 with arm AH. M2 8, 8 with arm PO. We say that this set of forces is equal to couple whose moment M, then M equals M1 plus M2. What is the M1? 3 times 8 root 3. The force times the distance. The force is 3. Distance between the two forces, 8 root 3, is AH. The second couple, 8 times 8 root 3. What is the 8? The force. What is the 8 root 3? PO, or length between the two forces, is 8 root 3. Answer is negative 40 root 3 kilogram weight dot centimeter. But in this case, dear student, look at another example. ABCD is a rectangle which AB 9, BC 12. Triangle is drawn outside rectangle with base AD and height 8 centimeter. Forces of magnitude 3, 6, 48, 36, 40, and 40 gram weight are applied along AB ray, AD ray, CD ray, DE ray, and EA ray respectively. Prove that the system of forces is equivalent to couple and find the norm of its moment. Solution. Look at rectangle ABCD. We have triangle ADE is an isosceles triangle drawing its base AD. Look at the force 40 act on DE and force EA act in with the force 40. Also, we have two forces 36 and 36 at act CD and AB. Remember, dear student, triangle EXD is an isosceles. In EXD, in EAD isosceles, but EXD right angle triangle at X. Then AE, what is the AE? AE equal ED, isosceles triangle, equals 6 power 2 plus 8 power 2 equals what? Equals 10. Then AE equals, by Pythagoras theorem, AE equal EX power 2 plus AX power 2 equals 6 power 2 plus 8 power 2 equals 10. The first 3, 6 and 3, 6 form a couple. What is the moment? The moment equal force times the distance. What is the force? 36. What is the distance? 12. Then M1 equal 432 gram weight centimeter. The second the three forces acting along A, D, E. Look at A, D, E in cyclic order. What you mean? We mean there is ratio between the force and the length of the side. F over L, 48 over 10 equal 40 over 10. We have, dear student, look at ADE. This triangle acts three forces on three sides. 48 act in ED, 40 act in DE, also 40 act in EA. What is the notes? We note that these three forces act on cyclic order. What's the meaning cyclic order? The ratio, there is a ratio or proportion between the force and side. The force F over L equal 48 over 10 equal 40 over 10. Then, dear student, by using cross multiplication, F over L equal 4 equal constant equal CK. The moment of the couple M2, the ratio X twice area of triangle ADE. Remember, in cyclic order, what is the moment? Twice area ratio times twice area of ADE. If you want to find the couple in cyclic order of a triangle, we find the ratio K times twice area of triangle ADE. Then 4 times twice area of triangle ADE equals half times base times height, AD times AX. By substitution, then the second couple is 4 times 12 times 8 equals 384 gram weight dot centimeter. Then the system is equivalent to a couple of moment sum of the first moment plus the second moment is 432 plus 284. Then the system in equivalent to couple of moment. Moment is the couple 816 gram weight dot centimeter. Now we are translate to another example. ABCD is a trapezium in which AD parallel BC, measure angle ABC 90 degrees, AB 8 cm, BC 17 cm, AD 11 cm. Forces of magnitudes 22, 16, 34, 20 gram weight act along DA ray, AB ray, BC ray, CD ray respectively. Prove that the system is equivalent to a couple and find its moment norm. Then find the two forces which act along AD direction, CD ray, CB ray, so that the system will be in an equilibrium. Look at the solution. Dear student, we have ABCD is trapezium. Look at BC is 17 cm, AD equals 11 cm. If we draw DH perpendicular to BC, then BH is 11 cm, but HC, remainder from 17, is 6 cm. First, we know that the cyclic order in triangle DCH or HCD, what is the constant K? 16 over 8 equals what? Equals 37, 34, over 17 equals 20 over 10, then k equals 2, 22 over 11. Each ratio is equals to this constant. This is the forces from a couple. What is the moment? M equal the ratio or the constant ratio times 2 area of a trapezium. What is the area of trapezium? Half sum of 2 bases times height, or base 1 plus base 2 over 2 times height. What is the ratio? Is 2 times twice area of trapezium. What is the area of trapezium? 11 plus 17 over 2 times height 2. Answer is 448 gram weight dot centimeter. Number 2, let the two forces B, F, and F act in AD and CB. Look at the couple equal moment equal 0, then negative F times 8 plus 40, 448 equals 0. Sum of moment of the couple equals 0. The first couple 448, the second couple, if two forces F act in AD, the second force in CB, the distance between them DH equal AB, each one 8 centimeter. We find negative F times 8 plus 448 equals 0, and then calculate the value of the force is 56 gram weight. Remember, dear student, F times 8, this couple equal the second couple which act at AD and CB in the opposite direction. Now we are translate to another example. ABCD is fine lamina in the form of a rectangle in which AB equal 18 centimeter, BC equal 24 centimeter, and weight 20 Newton, act in intersection of its diagonal. The lamina is suspended by a thin horizontal pin passing through a small hole near the vertex D, so that its plane is vertical. If a couple magnitude of its moment 150 Newton centimeter and each direction perpendicular to the plane of the lamina and axis of lamina, find the inclination of DB to vertical in the position of equilibrium. Solution. Look at, dear student, the lamina ABCD, AB 18 centimeter, BC 24 centimeter. Look at the distance between diagonal AC and vertical line is L. The couple is 150 Newton centimeter. The lamina is in equilibrium under two couples. What is the two couples? We say that the two forces 20 and R form a couple, its moment 150. Then we deduce that 150, the couple, equals the force times OE. What is the value of OE by substitution? OE equal 15 sine theta times 20 equal 150, then sine theta equals 1 over 2, then measure angle theta, shift sine half equal 30 degrees. Dear student, I am very happy to spend such time with you. Don't forget math simple, think, work, produce. Goodbye.